you have a sign-in sheet back there where you can add your email. One would serve and some information about our undergrad and graduate programs and funding, et cetera. There's some brochures. So thank you for coming today on our rainy week. We have to say afternoon, but it's the whole week. And I'll turn it over to Professor Lisa Naughton.
Thanks, Sarah. I'm Lisa Naughton, and I'm on the Faculty of Geography, and I'm also an affiliate of LASUS. And first, let me thank LASUS, the NAVE Speaker Fund, for contributing toward support for bringing Nora here. And as ever, LASUS is a great support and important actor in Latin American research across campus. So Nora is returning to Madison after many years of professional success. She was here years ago and finished 2 masters, one in geography and one in the Nelson Institute, and did her research in Peru on land cover change and how different presidential regimes shifted where forest was being cleared and where it was recovering. So she's from that stage as a master's been an innovator in showing physical signals from policy changes in Latin America. After completing her dual masters, she returned to Puerto Rico, where she's originally from, and served as director of the GIS program for the Department of Natural Resources for Puerto Rico. And after a few years in that leadership role, she decided to return to academia, and she's now a dissertator in the University of Puerto Rico, Rio Piedras campus, and is continuing to work on understanding how development policy and environmental policy affects real physical outcomes. So she's here today to give this brown bag, and she's also working with me and with Michaela, who's another LASUS grad student, on a teaching program we have that is based on our experiences in Peru. So join me in welcoming Nora back to Madison.
Hello, I'm very, very happy to be back in Madison. It means a lot to me, and thank you for LASUS to inviting me and for all the support that they have provided me in the past. I'm currently an NSF IGER fellow, and the IGER program in Puerto Rico tries to understand urbanization dynamics in the tropics. So the project I'll be presenting today is part of my research as an IGER fellow at the University of Puerto Rico. It's a collaborative research that I conducted with Dr. Mitch A., my advisor, and the urban planner, Isabel Perez Ramos. And this research, we're trying to contrast the patterns of urban expansion in 4 countries in Latin America. And we're doing that looking at the nocturnal lives of the earth. So as an introduction, I would like to mention that in 2009, only 5 years ago, the urban population surpassed the rural population at the global scale. So that means that there are more people living in cities than in rural areas right now. But despite this sustained urban growth, the urban areas occupy only 1% or less of the terrestrial surface. If we continue as now, the future population growth will happen in urban areas. And it is expected that in 15 years from now, the urban area, the extent of urban areas will double. So despite a generalized pattern of urban expansion, this is not happening homogeneously across regions. And it's interesting to know that South America is the most urbanized region in the world. That's surprising. You would expect that it would be Europe or North America, but it's actually South America. And in the future, in 35 years from now, projections indicate that 90% of the population in Latin America will live in cities. So we're talking that people are moving to cities We don't know how fast, we don't know the implications of this urban growth. But when we looked at the information, the current information about urbanization in Latin America, there are not so many studies exploring this issue. Most of the studies of urban expansion are in China, India, North America, but there's a gap of information about how our cities are growing in Latin America. So we decided to explore the use of nocturnal lights to analyze patterns of urban expansion. And we decided to do this in the Andean countries, the central Andean countries. That means Ecuador, Bolivia, Peru, and Colombia, because they have had recent patterns of urban growth. Between 1992 and 2009, 88% of the population growth in these countries happened in urban areas. And there are many reasons for this, but this country has a history of rural to urban migration. A lot of social unrest in the rural areas have promoted people moving to the cities, millions and millions, especially in Colombia and Peru. There are a lot of centralization of the economic activities and social activities. Therefore, some of the rural areas are being impoverished, and people tend to move to cities. So we're going to explore our methodology in these 4 cities. So nighttime lights are these images. Each of this bright light means a cluster of lights. And these are from the NOAA, the Defense Meteorological Program. It orbits the Earth twice a day, and the information is available for free. Information you can get from these images is a 1 kilometer resolution, and it's an annual global coverage, so I encourage you to take advantage of it. There are different products that you can get online, and the one we use are the permanent light sources. That means that ephemeral light sources are filtered out, such as fires. So most of the things we are seeing here, or in the product we use, are because of urban towns, maybe some mining activities, oil activities. The digital values of these images ranges from 0 to 63. 0 means absence of light, and 63 means a lot of light. We justify the use of these images to map urban expansion in Latin America because, according to the International Energy Agency, most of the urban areas in Latin America have electricity. So 99% of Latin America is electrified. And if we look at our countries of interest, it ranges from 78% to 94%. So we feel that nighttime lights could be actually a useful platform to study urban expansion in these countries. These images have had a lot of applications, and one of the applications is to relate the area of nighttime lights with population. And there is a clear relationship between the population and nighttime lights, and it's a linear regression. That means that as the cluster of nighttime light increases, there is an increase, or the opposite. As population increases, there is an increase in the area of nighttime lights. So what is the purpose of our study? First, we wanted to study, first we wanted to validate the use of nighttime lights to study urban expansion in these countries. We wanted to see the patterns of urban extent and compare them among countries. And then we went and looked at different examples, different cities in these countries, to see how they are expanding and which land uses are being converted to urban land uses. And we did this for all the municipalities in the region, about 4,000 municipalities in these 4 countries. Basically, I'm going to be talking about 4 steps: thresholding, classification of the images, the validation, and the calculation of urban areas. So what do I mean by thresholding? So first we needed to classify these images and relate the values of brightness with what's going on the ground. So we defined 4 classes of urban land uses. One is rural, no urban, scattered, suburban or intermediate, and then the compact land uses. And we used the QuickBird images in Google Earth to get some samples of these different urban land uses. Then we compared these land uses with their nighttime light values. And we found that there were clear differences. For each of these land uses, you had a minimum and maximum value of nighttime light. That means no development, the values of the lights went from 0 to 5. Scattered development, 5 to 20. And intermediate development had 20 to 52. And then the compact urban areas went from 52 to 63. And these were statistically significant. So we were pretty sure about these classes and how they represented different urban land uses in this region. So we classified the nighttime lights for the 4 countries. And this is an example in 2009, how they look. It's clear to see Lima, Brighton, Quito, Bogota, all these clusters of light representing these big cities, and also some small cities in the rural areas. Some of these lights are not towns, but mining operations or oil exploration. And as I told you before, for each of those 4,000 municipalities, we calculated the amount of light, and also we created a database for urban population. So for the 4,000 municipalities, we had how much area was in these different types of lights, and how much urban population is in each of them. And then we validated the use of nighttime lights. We needed to really understand if what we were seeing in the nighttime lights images was urban population. So we did some statistical analysis, and we found out that there is a clear and very strong signal with the values above 52 in nighttime light. So the high light area or the compact areas of nighttime light are explaining the urban population. And this was true for all of the classes, but the high nighttime lights are the ones who are really, really, really explaining the urban population at the municipality scale. We also decided to see, well, can I explain changes in population with these images? And we did a couple of other analyses of changes in urban population and changes in nighttime lights. And we found that you can explain 50% of the changes in urban population just looking at the changes in nighttime lights. So again, it's proof that these images are very useful to map urban interactions in these countries. So part of our results, we decided to look at the transition of municipalities among different light classes. And I'm not going to go too much into this, but what is interesting is that in our period of analysis from 1992 to 2009, we found 570 municipalities that went from having no light to having a source of light. And the amount of municipalities with a source of light also increased for the whole region. So there is a lot more to do with this that we haven't explored, but it will be interesting to see where are these municipalities that are now having a lot of light and probably a lot of urban expansion. Looking at patterns at the regional scale, we then added all these nighttime lights area for the whole region. And we found that the compact area, the urban area for the region, almost doubled in 17 years. And both in 1992 and 2009, it's Colombia and Peru that have the higher compact area, so they are the most urbanized countries in this region. But when looking at how much or how fast these urban areas are growing, we see that Ecuador and Bolivia have the highest urban expansion rate, whereas Colombia and Peru, the urban expansion are growing slowly as compared to the other one. It's interesting, we also look at the transition between classes, and for me it's interesting to understand that most, or a big portion of the lights in Bolivia came from no lights. So areas of no lights that suddenly are, have a big, bright urban area. If we look at population trends in this country, we are starting to see some patterns. For example, Colombia and Peru, the urban population in these countries are really high as today, 75 and 77. Their urban population, annual population growth is also high. But when you look at Ecuador and Bolivia, this is higher. You know, urban population is growing faster. The signal for urban areas is growing faster, but the current population living in urban areas is not as big as these two. So we're seeing two transition stages here in the urban transition theory. The urban transition theory states that there are countries with low proportion of urban population growth and low urban population growth. There are countries with a low proportion of urban population and high urban population growth. We have cities in the world with high proportion of urban population and a high urban population growth, and then high proportion of urban population and low urban population growth. And basically, the more industrialized the country, the more advanced in this transition theory. We see in here that Colombia and Peru are in a more advanced urban transition than Ecuador and Bolivia. So why is that? Okay, again, by 2009, 77% of the population in Peru and 75% of the population in Colombia lived in urban areas, but this started a while ago. So the urban population started to become bigger than the rural population in the 1950s in these countries. They urbanized very rapidly, but now they are experiencing a slower population growth, and therefore we're seeing a signal of slower urban expansion rate. The fertility rate in Colombia and Peru declined recently, and also the rural and urban migration in the past contributed much more to what is contributing now to urban population growth. It's still higher, but slower than in the past. And Ecuador and Bolivia, these are in intermediate stage of urban transition. And as you can see, they started urbanizing later in time. So it was in the 1980s when the urban population surpassed the rural population in these two countries. In these two countries, still rural and urban migration continues to be high, as in the past. And in Bolivia, fertility rates are faster than in the past, or continue to be fast. So for the first part of our analysis, I would like to mention that, again, urban expansion is occurring worldwide and it's occurring in Latin America, but there are some differences among how this urbanization is happening among countries. We can see that countries with longer urban growth histories are undergoing a lower urban population growth and reduced rates of urban expansion, as we can see in the nighttime light images. And countries in the early stages of urban population growth are expanding faster in response to urban population growth. In this part of the analysis, then, we validated the use of nighttime lights to monitor urbanization dynamics in this region. And it's, for me, it's good to know that there's some homogeneous platform to study urban expansion. because census definition varies among countries. Sometimes it's not, we are not dealing with the same type of information when we're looking only at censuses. So if you are looking for a more homogeneous platform to study urban expansion, I believe that nighttime lights is a good opportunity. Then in the second part of our analysis, we wanted to look at the city scale, what's happening in major cities in these countries. So we selected the major cities of Bolivia, Colombia, Ecuador, and Peru. And these were Bogotá, Medellín, and Guayaquil in Colombia. Bogotá, Medellín, Cali in Colombia, Guayaquil and Quito in Ecuador, Lima in Peru, and La Paz and Santa Cruz in Bolivia. We wanted to see how lights were changing in these countries in our period of analysis. So the first thing we did was to look for maps of cities, and there were no maps of these cities. Most of the maps are developed using the administrative boundaries of cities, so that means departments or municipalities, but the built-up area of these cities is not being mapped. So we decided to map these cities, and we used Google Earth, which was very useful. The QuickBird images in Google Earth are very high resolution, and we developed a methodology to say where are we going to stop calling it city or urban built-up. And that's how we managed to map all these urban metropolitan areas in the countries. And this is an example of how Quito looks. This is our delimitation of Quito, and these are the lights in 1992. That's Quito 2001, the lights, and 2008. So even though we're dealing with images that are very high resolution, they really are very close to what we call the real delineation of the metropolitan area. I'm going to show you some of the results. These are the countries in the main cities in Colombia. We see Cali, Medellín, Bogotá in 1992 and 2009. For this analysis, we added another class, it's a central core, because there was room for expanding the thresholding analysis of the nighttime lights. And the three cities have something in common. They were already very urbanized in 1992. In 2009, they didn't expand much. Most of the expansion occurred to the south. And in Medellín, most of the expansion is occurring in the foothills of the cities. Bogotá, most of the expansion has happened in mangroves, and Cali also in the marshy areas of the cities. We believe that the expansion of the city hasn't been very spread out because they're embedded in the Andean mountains, so there's a restriction, a topographic restriction in the development and expansion of these cities. So cities in Colombia are being densified more than spread out. Also, there are different projects in these cities to make them more densified and urban. For example, in Cali, that's an example of urban development right now. In contrast, you can see the images for Quito, 1992 and 2009. A lot of expansion occurring in the core area of Quito and also in the compact area of Quito. Quito is going to the east because to the west you have the Pichincha volcano and also high mountains. But we found that the expansion of Quito is occurring over fertile agricultural lands, so that's something to consider. And in Guayaquil, most of the expansion occurred to the in the Guayas River estuary and beyond the Guayas River estuary, also on top of marshy areas and mangroves. We're seeing now the main cities in Bolivia, Peru, Here we have La Paz El Alto. As you can see, a lot of expansion going on, but not in La Paz is very constricted again because of its topography. But then you have El Alto, which is a plateau very close to La Paz, and that's where urban expansion is taking place. Mostly because it's flat, no topographic restriction, but also because land is available and it's very cheap. And in Peru, Lima, most of the urban expansion, the compact urban expansion, is the formalization of pueblos jóvenes happening south of the city center. But still we see like two different patterns of urban expansion in Lima. One is that it's highly concentrated, but then another one that is more suburban. And in Santa Cruz, this is Santa Cruz. We can see also that the urban core is expanding, but what is expanding mostly is the compact or suburban area. So Santa Cruz is a very spread out city and also doesn't have any topographic or restriction for development, so it's growing along a very fertile agricultural land. So just to summarize, we see Bogotá, Cali, Guayaquil, and Medellín, compact and densifying cities. Quitos and Santa Cruz, expanding, very low density. Lima is a dual type of urban development, an area of high density, compact, but also suburbanization. And then we have La Paz, El Alto, which are expanding without any topographical restriction.
We do have a sign-in sheet back there where you can add your email. One would serve and some information about our undergrad and graduate programs and funding, et cetera. There's some brochures. So thank you for coming today on our rainy week. We have to say afternoon, but it's the whole week. And I'll turn it over to Professor Lisa Naughton.
Thanks, Sarah. I'm Lisa Naughton, and I'm on the Faculty of Geography, and I'm also an affiliate of LASIS. And first, let me thank
inviting me and for all the support that they have provided me in the past. I'm currently an NSF IGERT fellow, and the IGERT program in Puerto Rico tries to understand urbanization dynamics in the tropics. So the project I'll be presenting today is part of my research as an IGERT fellow at the University of Puerto Rico. It's a collaborative research that I conducted with Dr. Mitch A., my advisor, and the urban planner, Isabel Pares Ramos. And this research, we're trying to contrast the patterns of urban expansion in 4 countries in Latin America. And we're doing that looking at the nocturnal lives of the earth.
Presidential regime shifted where forest was being cleared and where it was recovering. So she's from that stage as a master's been an innovator in showing physical signals from policy changes in Latin America. After completing her dual masters, she returned to Puerto Rico, where she's originally from, and served as director of the GIS program for the Department of Natural Resources for Puerto Rico. And after a few years in that leadership role, she decided to return to academia, and she's now a dissertator in the University of Puerto Rico. LASIS, the NAVE Speaker Fund for contributing toward support for bringing Nora here. And as ever, LASIS is a great support and important actor in Latin American research across campus. So Nora is returning to Madison after many years of professional success. She was here years ago and finished 2 masters, one in geography and one in the Nelson Institute, and did her research in Peru on land cover change and how different Rio Piedras campus and is continuing to work on understanding how development policy and environmental policy affects real physical outcomes. So she's here today to give this brown bag, and she's also working with me and with Michaela, who's another LASIS grad student, a teaching program we have that is based on our experiences in Peru. So join me in welcoming Nora back to Madison.
Hello, I'm very, very happy to be back in Madison. It means a lot to me, and thank you for LASIS